So this is the answer for the fifth question. So now let's go to the next question. Guys, can you understand this one, number 5?
Yes, Omar.
Okay. So number 6, let f of xy be a continuous function. So after reversing the order of the uh, iterated. Maybe here's some typos. Iterated integral. So integration of 1 to e dx, integration of 0 to ln x, f of xy dx equal what? So, okay, this is continuous function. So we have to, after reversing in the order, okay. So let's see how can we find this one. 1 to e and 0 to ln x. So do you know what is the value of e? E is the Euler's number, right? 2.71828, right? 2.71828. So as you see here, our integration is 1 to e and then 0 to ln x. So on is here, right? On is here. And then 2.7, it will be somewhere around here, right? So I have written this part, 1 to e, okay? I have written them in the graph. And here we have 0 to ln x. So yeah, I'm recording this. So here is 0 to ln x. So 0 is here, and then ln x. If I put some value of x, so it will go this way. Okay, this way. The curve will go this way. For example, this is 1. So what is our function? 0 to 1 e to the power y f of x. 0 to 1 e to the power y, and then I'm not sure how to solve this one. Okay, I didn't also got the point how Lausi described this one. So I think we can skip this one. Okay. I just understood this part, like how this can be represented in the graph, but why the answer is A, I'm not sure. Reverse in order. So we got 0 to 1. DRD. Ln x and e to the power y. Ln x e to the power y. So guys, we can just skip this one because I don't know how to solve this one because I also didn't
Okay,
understand
Omar.
how Lausi described this one.
Okay, it's okay.
Part 3, we have some calculation problem. Solve the first order linear differential equation as follows. So you have to find the general solution and find the particular solution. So as you see here, you have to find the general solution first and then you have to find the particular solution. This is a first order linear differential equation because here you see here the order is 1, right? dy by dx. dy partial derivative of y with respect to x. So here the order is 1. And then the first thing first. So we can factor out. Okay, so So for the first question of part 3, we have a first order linear equation, that is e to the power x dy over dx plus 2 into e to the power xy equal 1. So we have to solve this. So first we have to convert this equation into something like a standard form. The standard form is y prime p to the power x times y equal q to the power q of x. Y prime plus p of x y is equal q of x. This is the standard form. As you can see here on the right side, uh, the dy over dx plus p of x y equal q of x. So this is the standard form. So as you see, y prime. So dy by dx, this is our y prime. Okay. If I zoom in this a bit, you can see. So here dy over dx. So this is the y prime, and then e of x, e to the power x. This is our we have to move this. Okay, we have to move this because only we have y prime, and then we have 2 here. So we have y here, right? Y here. So all this function, this 2 into e to the power x, this is our p of x. This is our q of x. We are still not sure which one is p of x and which one is q of x. So let's let's do a little more analysis here. Okay. So as you see here, I have just okay. I can just take e to the power x. I can just factor out e to the power x. So I am left with y prime. So I'm writing dy by dx as y prime, okay, because it is the same. And then if we factor out e to the power x, so we get 2y here, right? 2y equals 1. And then on the next line, we take e to the power x on the right side. So if we take e to the power x on the right side, so we get y prime plus 2y equals 1 by e to the power x. So 1 by something, that means e to the power minus x. Okay, it is e to the power minus x. E to the power minus x. So as you can see here, e to the power minus x, we got our standard form, y prime plus p of xy equal q of x. So here is y prime. So here p of x equal 2, and then q of x equal e to the power minus x. So that's why they have written here dy over dx plus 2y equal e to the power minus x. So this is the standard form. You can also write down this y prime plus 2y equal e to the power minus x. The same thing. And then we write down our p of x equal 2 and our q of x equal e to the power minus x. It is just I have just written them separately, so I can see them here, right? Our p of x from the standard form, our p of x equal 2, and then our q of x equal e to the power minus x. So they have written here separately, and then then you have to find v of x. So v of x is gonna be, this is the formula. V of x is going to be e to the power integration of p of x dx. Okay, this is another formula. So v of x is going to be e to the power integration of p of x dx. And then we just substitute our p of x here. So p of x equal to, and then integration e to the power, so integration of 2 dx, integration of 2 is 2x, right? Integration of 2 is a constant. We are doing integration with respect to x, so integration of 2 is 2x. So we got our v of x equal e to the power 2x. And then we have to look here. We have to so we already found u to the power. We already found our v of x, and then solve for y. So the formula is y times u to the y times u of y times v of x equals integration of q of x into u of x dx plus c. So this is also this is also another formula. So as you see here, so it is u of x. So let me write down it here so that this is, so we have to solve for y times v of x is equal integration of q of x times u of x and v of x dx plus c. So this is another formula. So as you see here, we have written here y, and then our v of x is here, right? Our v of x is here. So our v of x is here, this line. Our v of x is here, okay? Let me use another color. So this is our v of x. As you see here, we got our v of x in this line. So v of x is equal e to the power 2x. So that's why we have written here e to the power 2x. And then it is equal to integration of q of x. So q of x is here e to the power minus x. So integration of e to the power. Okay, then it is q of x times v of x, right? So q of x times v of x is here. So q of x is here, and then v of x is here. So we are going to multiply these two value. So q of x multiply v of x, it is going to be e to the power x. Okay, as you see here, we have e to the power 2x and then multiply e to the power minus x. So according to the formula, as our base is same, right? So for multiplication, we can just add the power. So 2x plus minus x, that means 2x minus x. So 2x minus x is e to the power x. Okay. So that's why here is e to the power x, and then dx plus c. So it is dx, and for c we don't have, maybe we don't have. Okay, so as you see here, e to the power x plus c. Okay, we have written here c, and this c is important. You must write down this c. So ultimately we can just rearrange this, and we got. So we just keep y on the left side, and we got e to the power 2xy equal e to the power x plus c. So we keep y on the left side, and we take e to the power x on the right side. Okay, so we got y equals e to the power equals c e to the power. Oh yeah, so if we take e to the power 2x on the right side, so it was multiplied with y, right? So it is now it is divided. Now it is this way. So if we take e to the power 2x on the right side, so we have to divide here, right? E to the power 2x. So now e to the power x divided by e to the power 2x, we have to uh, according to the formula. So it is e to the power x minus e to the power 2x. So that means e to the power x minus 2x. So it is e to the power minus x. So that's why I have written here e to the power minus x. Grace, do you remember this formula back in high school?
No.
Okay, let me explain. So I have as we see here, we have e to the power 2xy is equal e to the power x plus c. Okay. and then I am taking e to the power 2x on the right side. So as it was multiplied with y, e to the power 2x was multiplied with y. So now it is going to divide. It is going to divide. Okay. I mean, you can think this way. We divide both sides with e to the power 2x. Is that okay? Here is our left side, and here is our right side. So we divide the both side with e to the power 2x. So e to the power 2x and e to the power 2x get cancelled. So we are only left with y. And then here we have e to the power x plus c by e to the power 2x. So according to the 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 divide, according to the divide formula, okay. So if we have on only on function on the denominator, so we can write down this way: a by c plus a by c plus b by c. Okay, this is called I don't know. I don't know how to say in English. Okay, but this is the formula. If we have only on function on the denominator, then we can write down this way: a by c plus b by c. So that's the same thing here. Same thing for here. So you can write down this way: e to the power x by e to the power 2x, and then plus c by e to the power 2x. Okay. And as we know that here our base is same, right? E to the power x, e to the power x. So if the base is same, according to the formula, as it is a as we are dividing these two, so we have to subtract their power. So x minus 2x. So it is going to be e to the power minus x. Maybe it is the exponent formula. Exponential formula. So guys, can you see here? A to the power m, a to the power m by a to the power n is equal a to the power m minus n. A to the power m times a to the power n is equal a to the power m plus n. So there are laws for exponents. Okay. So the same thing we use this formula.
I get it, Omar.
So e to the power x by e to the power 2x is e to the power minus x. And then c by e to the power 2x, it is going to be c times e to the power minus 2x. Okay, because as e to the power 2x is on the denominator, so if we take this on the upside, so we will get a minus sign here. Okay, we will get a minus sign before its power. Okay, so that's why our answer is e to the power minus x plus c into e to the power minus 2x. So is that clear now?
Yes, Omar.
Okay. Now let's see the second question. Y times. Okay, y times. Okay, let me save this one and need this later. So now let's see the next one. Find the limit limit xy tends to 0. Okay, so here's the question. Yeah, here. So find the limit xy tends to 0, xy tends to 0 0 xy by root over xy plus 4 minus 2. So as you see here, if we substitute the value, okay, so if I substitute here x equals 0 and y equals 0, so it will become 0, right? So 0 plus 4 is root over 4, and then we have minus 2. So root over 4 minus 2, that is 2 minus 2. So 2 minus 2 is 0, right? So we got xy by 0. And then if we substitute the value of x here and the value of y here, so again we will get another 0 0 here, right? So 0 by 0. So this is a 0 by 0 format. So that's why we have to convert this limit into something else. So this type of equation, you have to multiply. You have to multiply using the conjugate. Okay. Let me show you. So this type of equation you have to multiply using the conjugate. So what is conjugate? Here is minus 2, right? Here is minus 2. So you have to multiply using plus sign. Okay, I mean the opposite sign. Here is minus sign, so you have to multiply using the plus sign of this function. So it is root over xy. This is root over xy plus 4 minus 2. We have to multiply root over xy plus 4 plus 2. Okay, on the both side, on both on the upside and both on the down, on also on the downside. As you see here, we have multiplied root over xy plus 4 plus 2 on the upside, and on the downside also. And now here we got a plus b into a minus b. So here a is root over xy plus 4 and b is minus 2. So a plus b into a minus b. So a plus b into a minus b is a square minus b square. So root over xy plus 4 whole square. This was our a, so a square minus b square means 2 square. So we can cancel out a square and root, and then we are left with xy plus 4 equal oh sorry, xy then 2 square equal 4, right? I have to delete some of them, they are taking too much memory. Okay, so can you see here 2 square, so 2 square is 4, so we got xy plus 4 minus 4. So ultimately it is xy, only xy, right? Only xy. And then we have xy on the upside, so we can cancel out this xy. Okay, we can cancel out this xy. We can cancel out this xy. Maybe it is little messy. Let me erase this and let me explain again. So as you see here, if we substitute back the limit here, so we get 0 by 0 format, and that's why we have to multiply the conjugate. So here it is minus sign, so we have to multiply using the plus sign. So root over xy plus 4 plus 2. Okay, we are multiplying with the plus sign with in upside and also in the downside. Then on the denominator, here is a plus b into a minus b form. If you look here, a minus b into a plus b form. So a minus b into a plus b is equal a square minus is equal to a square minus b square. So do you remember that formula? That's why a square means xy plus 4 whole square. So we can cancel out a square and root, right? So we get xy minus xy plus 4. And then b square means 2 square. So a square minus b square. So b square is 2 square. Okay. So 2 square equal 4. So we got xy plus 4 minus 4. So we can cancel out plus 4 and minus 4. So we get xy. So I can write down here xy. And then we can cancel out xy from upside and downside. So we are left with root over xy plus 4 plus 2. And now we have to substitute back the limit. We have to substitute back the value here. So here is root over 0 plus 4 plus 2. That means 4. The answer is 4. Okay. So now we get some real number. So this way we solve the limit. Grace, can you understand?
Yes, Amar, I get it.
Okay. Now let's see the next question. So we will join again because we have a name.